In this video, I want to take a minute to explore what is the sum of the interior angles in any polygon, doesn't matter what size. Now, we already know that if we add up the interior angles of a triangle, that's 180 degrees. And if we add up the interior angles of a quadrilateral, that's 360 degrees. And I've gone ahead and filled out this table for different sizes. For a pentagon, 5 sides is 540 degrees, 6 sides in a hexagon. The interior angles add up to 720 degrees. In a 7-sided septagon, the interior angles are 900 degrees. And in an octagon, the interior angles add up to 1080 degrees. So you can see that there's a pattern forming in this table, right? It seems like it's always 180 degrees more when I add another side. And that pattern just keeps going. Every time I add a side, I add another 180 degrees to the sum of the interior angles. So if I wanted to try and write down a formula for that sum, I would say that it's the number of sides minus 2 times 180 degrees. Okay, so 3 sides, take away 2, that'd be 1 times 180, 180. 4 sides, take away 2, that'd be 2 times 180 is 360. 3 times 180 is 540. So I could say one formula is the number of sides minus 2 times 180. Or if I use the distributive property to multiply that out, another way of looking at the formula is 180 degrees times the number of sides minus 180 times negative 2, so minus 360 degrees. Either one of those formulas would give me the sum of the interior angles for a polygon with n sides. All right, I'm back, and I just drew a couple of quick pentagons to demonstrate how these formulas work or why they work the way that they do. Okay, so if you think about the n minus 2 times 180 degrees, this is why that formula works. Take my pentagon, and I'm going to divide it up into triangles. So I'm going to divide it up like this. I'm going to start at one vertex, and I'm going to split it up into triangles by drawing diagonals to the other vertices. Now I can always split up a shape into 2 less triangles than there is the number of sides, right? So for a pentagon, there's 5 sides, I can make 3 triangles. I know that the sum of the angles in each one of those triangles is 180 degrees. 180, 180, 180. And since I can always make 2 less triangles than there is the number of sides, so that's n minus 2, the sum of the interior angles is always n minus 2 times 180. That's why that formula works. Now, what about this one? 180 times the number of sides minus 360. Why does that formula work? I'm going to just put a new point somewhere, anywhere in the middle of this polygon. So let's go right there. It doesn't have to be the exact middle, just somewhere inside the polygon. Now I'm going to divide the polygon into triangles from that point. So something like this. Right there it is. Now every time I divide a polygon into triangles like this, I'm going to get the same number of triangles as there is number of sides on the polygon. So this is a pentagon, I got 5 triangles. I know that every one of these triangles, sum of the interior angles is 180 degrees, and since there's 5 of them, this one would be 5 times 180, or like I said, however many sides there is, that's how many triangles I'll make, so the interior angles would be 180 times n. But wait a second, if I add together these triangles, I'm adding too much angle into this sum, right? I'm adding together all of this, which isn't actually part of the interior angles for this polygon. Well, how much did I add too much there? And I'll take it away, right? How much did I add that was extra? A full circle, 360 degrees too much. So that's why I take away 360 degrees. Either way, you get the same formula. Take 2 away from the number of sides, multiply it by 180. That's the sum of the interior angles for any polygon.